Hi, it's DK. We're going to continue with our video talk on number systems. This is where we kind of left off last time. All right, so let's go ahead and start this up. So let's say we want to convert the number 52 decimal to binary. All right. So what Professor Mayhew did in class was, depending on what the number was, we determined whether it's even or odd. If it's even, you'd put down a 0. If it's odd, you put down a 1. Well, we'll continue that. We're going to do it a little bit mathematically so you can maybe see it in a different way. So we have 52. We're going to take the 52 and divide it by 2. And so basically what we're going to do is take the 52 divided by 2. That gives me 2, 4, 1, 2. So give me 26 minus 12. Remainder 0, right? That's my remainder. So that's my remainder right there. And we're going to take this 26, okay, and stick it here in the new number, new division. So we're going to do 26 divided by 2. When we do 26 divided by 2, that's going to give us 13 with no remainder, right? So remainder 0. Then we're going to do the 13 divided by 2, which will give us 6, right? It'll give us 6. All right, and then we're going to take that 6 divided by 13 divided by 2 would be 6 rather, with the remainder 1. Take that 13 divided by 2, which gives us 6. 6 divided by 2 will give us 3, all right? And 6 divided by 2 will give us a remainder of 0. 3 divided by 2 will give us a remainder of 1. And so at this point right here, we have 3 divided by 2, right? Okay. And that gives us 1, and I'm sorry, yeah, 3, sorry, this will give us 3 divided by 2, which is 1, remainder 1, so that's your remainder 1 here, okay? And then you have 1 left over, so 1 divided by 2, which is this operation right in here, gives us 0 with the remainder 1, okay? With the remainder 1, so that's your remainder 1 here. All right, so what we're going to do with these numbers is, you can do even odd, of course, is start putting them down in a numerical system. 0, 0, 1, 0, 1, and 1. All right, and that's our result: 1, 1, 0, 1, 0, 0. Right, so it's a fairly simple way to do things. Again, Professor Mayhew gave you a very excellent way to do these computations, determining whether it's even or odd, and then dropping the remainder. How about 101? Shall we give this a whack? All right, make sure that we can do this. So let's give it a whirl. All right, so I'm going to take the 101. That's going to want, oh shoot. So let me go back here. There's a little button on this little pen that just drives me crazy. All right, so we have 101. So 101 divided by 2 will give me a remainder of 1. This guy will give me a result of 50, right? Divided by 2 will give me a remainder of 0. And so 50 divided by 2 will give me 25. Divided by 2 will give me a remainder of 1. 25 divided by 2 is actually 12, remainder 1. So this will give me 12. So 12 divided by 2 will give me a remainder of 0. This computation, 12 divided by 2, will give me 6. And then 6 divided by 2 gives me a remainder of 0. And 6 divided by 2, the computation will give me 3. Okay? 3 divided by 2 will give me a remainder equals to 1. This is 0 here. And 3 divided by 2 is 1 with the remainder 1. So that'll be 1 over 2. So the result will be 1. Remainder 1 there. Okay, so So writing the numbers, we'll have 1, 0, 1, 0, 0, 0, rather 1, and 1. So the result will be, I'll rewrite it here, 1, 1, 0, 0, 1, 0, 1. Okay, 1, 1, 0, 0, 1, 0, 1. Correct. So I'm going to confirm this on the calculator just to make sure that the numbers work out. 101 decimal converted to binary is 1100101 for sure, right? Okay. So we can do it with other number systems too. We can do all of this with other number systems. How about converting it to hexadecimal? All right. So we can convert that to hexadecimal, actually rather easily, if you convert it to binary first. All right. So so one way, the fast way to do this, okay, possibly one of the fast ways to do it is to convert it to binary, and our binary number, if I remember right, was let me put that in there again. Binary number was 1100101. Okay, so we're going to group it into 4s here. I'm going to put a leading 0 on here. I'm going to put a leading 0 on there. There we go. And we know that this number here, 0101, is equal to, let's see, this is the 1's place, this is the 2's place, this is the 4's place. So this is equal to 5, all right? This guy here, this is the 1's place, the 2's place, the 4's place. So this would be 6. So the number will be converting it from decimal to binary to hexadecimal will give us 6, 5 hexadecimal, all right? Base 16. Now the way to write base 16 here is 0x. That indicates that it's hexadecimal, and then I'm going to write a 65 there, all right? By the way, this number right here, this binary number, the 01100100, we can write that as the following. You can go 0b, all right? That indicates it's a binary number, and 01100101. Okay. Okay. Now the alternate way to do this is go ahead and divide everything by 16, 16, 16, etc. So let's go ahead and do that. So we had 101. I'm going to divide it by base 16. So I'm going to set this up, my calculator up, so that I'm not wasting too much of your time. So 101 divided by 16 will give me a remainder 5. Okay, remainder 5. This is my remainder column, and that result will give me 6 with a remainder 5. All right. So if I do 6 divided by 16, okay, that'll give me remainder 6, and the result, of course, is going to be 0. So 0 remainder 6. So there you have it. This will be in the 5 column, the first column is rather 16 to the 0th column, 16 to the 0th column, and then this guy 6, the remaining number here, the remaining number there would be 16 to the first column. So your result will be 0x65. All right. Binary to hexadecimal, pretty darn simple. Just group them up into 4-bit chunks. All right. So what I did was I wrote it up so it's grouped up into 4-bit chunks. So that looks like this is the 1, 2 to the 0, 2 to the first power, etc. So this will be 2. This will be 2 to the 0th power, which is 1, 4, 8. Sorry, 1, 1, 2, 4, 8. Okay, so it'll be 1 times 8 plus 1 times 2, which will give us 10. But you know, 10 doesn't exist in hexadecimal, right? So we're going to have to convert that to A, all right? Because 10 decimal is equal to A hexadecimal. This guy, 0001, is just 1 hexadecimal. And this guy here would be the 1's column here, 2's column there, there's the 4's column, so this will be 5, okay? So if we wanted to convert this binary number, which is 0101, 0001, 1010, 0010 to hexadecimal, will give us OX 51A2. Okay, 51A2. How about if we want to convert that to binary? Well, you guys know how to do this already, all right? So let's just give it a whirl. So we've got 5, all right? 5 in binary. 5 in binary is 0101, okay? And then 2 in binary, this is decimal. This is hexadecimal, hex. 2 in binary is equal to 0010. So this is the 5, okay? And this is the 2. F in hexadecimal to binary would be 1111. And then A in hexadecimal to binary would be, we know that A is equal to 10 decimal, right? 10 decimal, 10 base 10. We know that F is equal to 15 base 10. Know that A is the number 10 in base 10, so that's going to be 1010. And so our result will be, I'm going to take it from the A part, okay? Most significant bit. Most significant digits, so it'll be 1010, 1111, 0010, 0101. Okay, so that is our binary equivalent to hexadecimal AF25. All right. Great. Let's see. I think I just have one more slide that just covers what we did, which is number systems. We did some number system conversions. The next slide step will be some mathematical manipulations of binary systems. And so I'll see you then.